Greetings and welcome to lecture number 63. This is our chem review number 3. Let's see what we can do. All right, I'm going to try to get the balancing right today. All right, I had my coffee, feeling good. So let's see what we have. All right, we're going to balance and we're going to name and see if we can see what kind of reaction. Just as a review, kind of do a couple things at once. Okay? All right, so what do we have here? We have C5H12. You remember what that is? That's an alkane, N2N plus 2. 5 is pent, so this is pentane. We're adding oxygen. We get carbon dioxide and water out. So when we get carbon dioxide and water as the products, we know that this is a combustion or oxidation reaction. It's complete combustion. We get carbon dioxide. If it was incomplete combustion, excuse me, we would also have carbon monoxide. Okay, so we have an alkane, the pentane, adding oxygen. So we're burning this pentane. We're getting carbon dioxide and water out. Okay, this is not an easy one. This is not easy. Just remember, on an exam, I cannot ask really hard ones. I do not want you to spend 20 minutes just on one balancing problem. It's 2 points. Okay, so I don't want you spending a lot of time. So my exam questions will not be as complicated. The reason I'm doing it a little more complicated here is because you have time, you're playing, it's just a math game, do it with your kids, but I want you to understand the concept, right? The concept when we balance is that the same number of each element on the left side must be the same number on the right side. We start with 23 carbons, we must finish with 23 carbons and so forth. That's the whole idea. The rest is just like Sudoku or something. We're just doing a number game. We're trying to count and balance, okay? This balancing is not so easy. The first one's not so easy, okay? Let's see. Okay, let's see how that goes. All right, let's see if I balance it. That's an O2. O2, sorry, O2. Sorry. All right, let's see. All right, let's count. 5 carbons. 5 carbons. So far, so good. Go home. Just kidding. All right, 12 hydrogens. 6 times 2, 12 hydrogens. Fantastic. 8 times 2 is 16 oxygens. 5 times 2 is 10 oxygens. 6 times 1 is 6, 16 oxygens. We did it. We balanced that one. Okay? All right, let's look at the next one. Zinc plus HCl. What is HCl? All right, once again, not tricking you, but be careful. HCl by itself is hydrogen chloride, right? Hydrogen chloride. Hydrogen chloride is a gas. If I wrote HCl aqueous, AQ, hydrogen chloride aqueous is what we call hydrochloric acid, right? It's monoprotic. It wants to give up 1 proton. In solution, the H plus, it donates an H plus, and there's a Cl minus ion. Okay? So whether we call this hydrogen chloride or hydrochloric acid, for us, it doesn't matter right now. We get zinc chloride, okay? Plus hydrogen gas. So we need to balance this one. This one doesn't look so bad. I don't think. Let me make sure. Okay. Oh, I already put a 2 here, right? There's a 2. The 2 already took care of the hydrogen, didn't it? 1 zinc, 1 zinc. 2 hydrogens, 2 hydrogens. 2 chlorines, 2 chlorines. Easy one. This would be on the order of something you would get on the test, okay, an exam, because this could be done quickly. Now, I could say what's the coefficients? It would be 1, 2, 1, 1. Or I could say when this equation's balanced, what is the sum of the coefficients? It would be 3, 4, 5, right? So it would be 5, the sum of the coefficients. And so I could ask this question in a number of different ways. All right, let's look at the next one. I keep putting in answers. I don't know why, but that's okay. Okay, let's look at the next one. CaO2, right? You know that. That's calcium hydroxide. And we're adding it to H3PO4. Once again, if this was aqueous, we know this is the triprotic acid, phosphoric acid. If I don't see aqueous, technically, this is then hydrogen phosphate, hydrogen phosphate. Or again, in solution, it wants to give up 3 protons, so it's triprotic, and this would be phosphoric acid or just hydrogen phosphate. What's happening is the calcium's going with the phosphate, etc., and we get water out. So what we're doing is, looks like maybe a replacement here. The calcium's replacing that, and then the water. So it's a double replacement. We get calcium phosphate and water out. And how can we balance this one? Let's see. Not so easy. Okay, let's try it. Let's see what we get. 3 calciums. 3 calciums. So far, so good. Good check. All right, we got a lot of oxygen. So let's do. There's 2 oxygens in this hydroxide, but we have 3 of these calcium hydroxides. So 3 times 2 is 6 oxygens here. Then we've got 4 oxygens in this phosphate polyatomic ion. So 4 times 2 is 8. 3 times 2 is 6. 8. So we need what? 6 plus 8 is 14, I think. My mind. All right, let's see. Here in this phosphate, we have 2 times 4 is 8, plus 6 is 14. Oxygen looks balanced. Move on to the hydrogen. See if this is good. There's 2 hydrogens in this hydroxide, so that's 6. 2 times 3 is 6, so it looks like we have 6 plus 6 is 12 hydrogens initially. Hydrogen. Oh, 6 times 2 is 12. Yay, I did that. Good. And finally, we have 2 of these hydrogen phosphates or phosphoric acids, but we have 2 phosphorus, and here in this phosphate, we have 2 phosphate ions, 2 phosphorus, so it looks like the calcium, the oxygen, the hydrogen, and the phosphorus all add up. Okay? All right, let's look at the next one. Next one's, again, pretty straightforward, pretty easy. So let's name this, right? This is iron chloride, right? Oh, be careful. We got to be careful. Remember, chlorine is -1. So that means this iron must be +3. If it's +3, we can say this is iron 3 chloride. Or, you know the other one? Ferric chloride. Ferric chloride. Ferric chloride. If we had FeCl2, right? Then that would mean the iron was +2. This is ferrous chloride, or iron 2 chloride, right? But here we have iron 3 chloride or ferric chloride. All right, here we have the polyatomic NH4, ammonium. We have the polyatomic OH with a minus is hydroxide. So this is ammonium hydroxide, ammonium hydroxide. What's happening is the iron is stealing away the hydroxide, and the ammonium is going with the chlorine. So this is a double replacement. So again, this is iron. Since this is right? -1, this has to be +3. So this would be iron 3 hydroxide or ferric hydroxide, okay? Iron 3 has to have a +3. And this is clearly ammonium chloride, ammonium polyatomic is +1. Chlorine, a halogen, is in group 7, so it has a -1 oxidation number, +1, -1, that's good. And so we named everything. Okay, ferric chloride, ammonium hydroxide, ferric hydroxide or iron 3 hydroxide, and ammonium chloride. So now we named it. Fantastic. Let's see if we can balance this. Again, as I said, this doesn't look too bad, I think. All right, let's see. See if this works. I'll take all these oxidation numbers away, and let's see what we have. Let's see if we did this. See if my mind's working for this one. All right, we have 1 iron here. I have 1 iron. Okay, iron's good. I have 3 chlorines in this ferric chloride, 3 chlorines. And here in the ammonium chloride, I have 3 chlorines. So chlorine's good. Iron's good. How many nitrogens? Three nitrogens from this ammonium. Three nitrogens, three nitrogens. Hydrogen, 3 times 4 is 12. 3 times 4 is 12. That's good. Oxygen, three oxygens from the hydroxide group here. And hydrogens, three hydrogens, three hydrogens. 3 times 4 is 12. Sorry. Boy, did this not balance again? Is that not balanced? Oh, why did I put a, what is that? Is that right? Three chlorines. Oh boy. I said oxygen's balanced. NH4, 12, 15. Oh, I just can't count, so pay no attention. All right, let's look. 3 times 4 is 12, right? And then 3 is 15. Three hydrogens there is 15. Very good. Three hydrogens here and 12 hydrogens there is 15. So the hydrogen's okay, everything's okay. And senile one just can't count. Once again, when you're very close to the board, it's a good excuse for age, but pay no attention. All right, this last one is really hard, really hard. Okay, so let's see if you can get it. It's not easy. Wow, not easy. But I'll give you the answer anyway, because I know you worked on it for like an hour, right? I would never give this on a test, just so you know. Tell me if that works. Eight, eight sulfurs. 24 times 2 is 48 fluorines. 8 times 6 is 48. Oh, I got through the balancing today. Okay. So once again, uh, this would be typical of an exam. This would be typical of an exam. Maybe this would be on an exam also. Okay, but I want you to be aware also, not just the balancing, but again, you should be able to name these things: calcium hydroxide, hydrogen phosphate, or again, aqueous, phosphoric acid, calcium phosphate, water, ferric hydroxide or iron 3 hydroxide, ammonium chloride, ammonium hydroxide, again, ferric chloride or iron 3 chloride, etc. Okay, so I want you to practice naming and practice all that stuff. Be aware, if I'm going to give 50 questions in a very limited number of amount of time, I cannot ask really, really, really complicated questions. If I ask complicated questions here, or if I ask them when you do the homework, it's because if you can do the really hard ones, the easy ones you'll be able to do very quickly, and so time will not be such a factor. Okay? Well, all right, good luck. Keep practicing and stay healthy. Be safe. Peace. Ciao.